Hi, welcome to this workshop on hand and body tracking in Spark AR. My name's Balraj and I'm an AR developer and designer based in London. We'll be making a basic version of our team's project Infinite Reach. Alongside Hazel and Beth Wickerson, we produced this effect for the last hackathon. The idea for Infinite Reach was an effect where you as the user are in control of moving seamlessly between the metaverse. We used hand and body tracking so that the user can grab the effect from the sides of the screen, play with it, and then when they're done, clap to move on to the next one. We curated a series of visual shaders to have this journey as a visual fun experience. We also used SDF instructions and we had to think about how to work as a team across international time zones. We were across the UK, Europe and the USA. One of the most fun parts about working on a project like this is how each member can bring a new perspective to the project. While you might approach a problem one way, someone else might have a completely new approach, and that's really fun to explore and come up with these kind of new ideas. Let's start with the starter file. For our project, we combined some of the hand tracking template and some of the body tracking template. So to start with, we have our values from our device, and we will be using a screen offset later too. Here we've got the values from the body tracking. So we only care about the hands, but we use the wrist values because we found it worked better for our use. So here we've taken the right arm, the left arm, these are all part of the template, and put them into the positions. I've already connected some planes so you can see that they track each of these points and where they are. What we're going to want to do is have them collide together, so it's like a clap, and to these edge points here where I've already provided. So let's just bring these down here. And let's unpack the value, add some smoothing, let's keep it low at like 75, and let's copy that for each channel. And let's pack it again so that we can feed it back into the position. Let's check. There it is. And let's group that up. Let's call it exponential smoothing right. And let's copy it for the left one. Let's call it left first. Feed it in. Now we want to check for the collisions. So let's get these handles. I've got right handle, left handle, we want to drag them in. I've got one for the left, one for the right. Let's get the local transform so we can get the position and compare that. So let's unpack it. And let's also unpack this one again. So what we need to do is use the equals to compare the x values and the y values. So if we put in the x here and the x here, let's set a value for the tolerance. So let's say it's 60 and put it in here. Now the y is bigger, so while we can copy and paste this, let's multiply the tolerance by 1.5, just so it covers that bigger area. Let's connect the y's, and we want to check if the first one is true and the second one is true. So if the x and the y values are collided. So let's pack it up into a group. And let's call this collision R. Let's edit group properties and make sure there's an output there. Let's go in and connect it up. Then we need to change it to a Boolean. Change it here. Put it back in. Now we can connect it. Okay, so we want to copy this for the other hand as well. Let's rename it so it doesn't give us an error. Connect the left handle into input 1, hand position, and with this, what we want to do is use a sender to check that the right hand has been collided with the right handle. So let's make it a Boolean and let's call it detect left. This one's a right grab. Let's do the same for this one and we want to call it detect left. So a lot of this is double because you've got two hands and two sides. So next what we want to do is check for the clap. Let's put some visual feedback for these grab interactions. So we want to say if this happens that these will change colour. Let's take this value and use it for the pulse to start an animation. And when the pulse is off, to reverse it. Let's set this to be really short. And use a mix to mix between two different colours. Let's go with just white for the start and let's choose some bright colour here. Let's use blue. And let's use this progress to drive the alpha value. And now we want to mix it. And now let's apply that to the material which we have for these handles. So let's go for the right one. It's called grab right, and let's connect that in to the patch. So let's see what happens. Here we go. When it collides, it changes colour, which is what we want. So now let's duplicate that for the left. So when the left collision happens, let's get the material for the left handle and have it change colour. So here. Now let's move on to the clap. Now for the clap position, we need to put in some checks to say that these body tracking points are actually on the screen. Because sometimes what happens is that it thinks it's at 0 or the edge and it registers those as a collision, but we don't want it to do that. So let's just make a bit more space. And what we want to do is we want to get these hand positions again, well, wrist positions, and unpack those. And what we want to do is compare it to the screen offset. So let's get it here. And first we want to say, is this value bigger than 0? So we want it to be in the screen. And also less than the x of this. Let's unpack that as well. Vector 2, the x. But also what you can see here is this value is negative and we need it to be positive, so let's get the absolute of the value instead. And there you can see the value is always positive, which makes it easier for us. And we want to do the same for y. So we say greater than 0 and less than the y value of the screen offset. And we want to do a bunch of ands, so we're comparing all of these. So it's only when all of these are true that it will detect as a collision. So what we want to do is we want to do the same for the other hand. So again, we need more space. We can also group the other parts that we don't need to look at anymore, but it might just be easier to have them all here for visuals. So let's copy all of this, apart from the unpack, and select them all. It's a little bit hard to see. Bring them all down, and let's put in this left value here. Let's take this one. What we also want to do is compare these positions to each other. So like the same as we did before, put this down, and we want to use it equals. So let's set the tolerance to 80, and we want one for the x and one for the y again. So we want this x value and the other hand's x value, the y value and the other hand's y value. And what we want to do with those is put them into AND again. So that one position equal to that one, and then more ANDs to connect these up. So is there a collision, and are the tracking points in the screen? And one last one, bring it all together. And this will show you if there's a collapse. So let's use a sender again so that we can use this value later on. And let's call it clap detected. We can group this up now since we don't really need to look at it again. So let's group it up and say clap detection group. Add some visual feedback like we did to the edge detection. So let's copy the same that we used, and let's change the color to something like green and get that true value out of the patch group so that when there's a clap, let's get hand material and apply this color to the texture. Now let's see what happens. So it's not detecting a clap. Let's go back inside the group and see what's going on. So here, let's do it. If we follow this line back down here, we still have less than 0 and less than 0, and greater than 0 and greater than 0. So greater than 0 is right, but we need it to be the same as up here where we have the screen values put into the less than. So let's take the x and put it into there, and let's take the y and put it into there. Now let's see. So it's kind of working, but it's always detecting a clap if they're at the same mirrored position. So the reason is we're using absolute, and yeah, sometimes the hand tracking points or body tracking points glitch. So let's restart. That's better. Let's get these unpack values without the absolute, and let's use those for this to check if the positions are the same. Let's do the same for each hand and get the value in from there, and let's put the x and the y and the x and the Y second. So let's have a go. There we go, that looks better. Let's test it with some of the demo videos just to see. So here you've got the edge detection. And he's not clapping, so that looks okay. And here, yeah, that looks like a clap. So it's working how we want it to work. Okay, now we have those initial indicators set up. Let's look at the position and rotation of the frame that will be in between your hands. So from the hand tracking template, let's get in some patch facets. One is hand calculations and the other is angle calculation. So let's bring those in. So let's go to this video. It's a bit easier to see. So this is called effect between hands. And right now it looks massive. But let's get our wrist values again. So let's get some receivers. And let's get our left wrist and our right wrist. Let's get our screen ratio as well, because we need that as a receiver. Screen ratio. Now let's unpack this right and left wrist. And add together the X and the Y's. So let's add together the X's. And let's add together the Y's. Divide those by 2. And copy and paste for the other one. And pack them into a vector 3 because our plane has 3 values. We'll leave our Z as 0. So let's get the effect between hands and set the position to be equal to this. Right, next we want to look at how to scale the frame and transition it when there's a clap or a grab happens. We won't be looking into the further parts of this project that change it with the claps and grabs because then it will be a really long tutorial, but you can use these interactions for your own ideas. So when a grab happens, then it triggers something else to happen, or when you clap, then something's colour changes, for example. Let's do the rotation because that's quite simple. So let's get the rotation here. And what we want to do is we want to get our wrist values again. And we want the X and Y's of those. So let's get this and swizzle it. So let's get the X, Y, let's copy and paste it for the other. And what we want to do now is get those patch facets. So let's feed them into hand calculations. And feed that into angle calculations. Negate it. And swizzle it so it is just one value output. So swizzle to 0, 0, Z. So it means nothing for the X, nothing for the Y, and the Z value is the Z. And let's put that in. Now let's do the frame scaling and the frame transition. So for this we need the screen offset. So again we've got our unpacked wrist values and we want to use them again. So let's find the distance between the x value and the y value of each of these. Again, it's a lot of double of each patch because you've got the two values. If you were working with 3, then it would be 3 values. Let's add those together, the distance between those. And we can multiply this by how much we want. Smooth it a bit. So that the movement isn't too jaggedy. And we want to use this part here, the multiply, and divide that by the screen ratio. So let's put a divide in. Let's feed the screen ratio there. So this should really be a vector 2 because there's 2 values. And let's pack it into here. Oh, let's exponential smooth that first. And feed it into the output, but we want the Z to be 1 as well. So now we can take that and put it into the effect between hands scale. Let's see. There you go, you can see it's looking a lot better. Let's have a look at the scene. You can see it moving between the hands. While we can see it moving correctly between the hands, it's a bit small, so that's why we have this multiplier in here. So let's times it by 10, and you can see that looks better. That looks more like our project. But you can scale this to however much you want, and it will adjust to the hand sizes, but fit within the screen to whatever you think looks better for your idea. We also had a part of the project which changes this scale depending on what happens between a clap and a grab. This is to make a smoother transition. So let's add that, even though it might not be what we're doing for the full project, but it's good to have as part of how to transition between different scales when an event happens. So we want to get some receivers to detect when there is a clap and when there is a grab. We want one for the left and one for the right. And what we want to do is to, like we did for changing the colour of each of these planes when a collision happens, is use animation in a similar way. So let's use an animation node and some switches. So when a clap happens, we want to turn off the switch. So it automatically connects this pulse in between, which is what we want. So when the clap happens, let's delay it actually, because we don't want it to turn off straight away. So delay by 0.1 seconds. Let's put it into this, and we want to turn it off. Let's disconnect the flip because we don't want that. And we want to say when the left and the right happens. So it means there's a grab on both sides happening at the same time. Let's send a pulse in to turn this on. And we want to send a pulse here to play the animation when it's on and to reverse it when it's off. So you've got a smoother transition there. And now we want to add a transition. which our progress will be connected to that progress. And again, this is down to whichever size you want the rectangle to be. We're using 9,999 for the X and 12,000 for the Y, and we want the Z to be 1, just remember that. And our end will be fed in from here. And we want to put this into the 3D scale. So you can see it's quite big to cover up the whole screen. In our project, we use this with different visibilities to show this plane when we want it to and hide it when we don't want it to. But for this project, you can see that if I raise my hands up, this rectangle is between them. So we won't be going further than that, but you can use this in whichever logic you want to use it in. Another part of using body tracking for better experiences is that to make it work as the user would. So you can see this, there's no hands, but the frame is still there. We found this was not too bad and it was workable. But a part of this that I would improve is having the hand tracking, the wrist tracking even, to collide with the side of the frame regardless of how high or low it is. So at the moment we just use the distance, and so you can see the glitch happens again. So it's reset. Say we want the wrist to detect a collision no matter how high or low it is, because we were just using distance from one point. So let's look at improving that, because a user is going to think this is the whole side of the screen, so we want to be able to collide with this indicator. Otherwise, you can change your side indicators to match the distance that you've set it to. And so let's do that. So let's go back to our grab detection. So collision R. And let's have a look at what values we're using. If we think about it, we want this wrist point to collide depending on the X value. At the moment it's got X and Y, but up here it's still the same X, down here is still the same X, only the Y changes. So let's remove the Y because that shouldn't matter. So the Y goes into here and here, so let's disconnect that. So we've got it here, collide. Here's the other hand. Oh, we've still got the and. So let's bypass that and. So here, collide, here and up, collide, down, collide. So that makes for a better experience. And let's remove these patches that we don't need anymore. So we don't need this, clean it up. So we're just using the X value, and let's do the same for the left hand. So down we go to collision, and let's bypass the and first. Let's get rid of it, get rid of the second equals check and the multiply. So here with the other hand, collide, up, collide, and yeah, just keep refreshing if the body tracking points do stop tracking. So now we've got the rectangle between our hands, collisions, detecting a grab, and a clap. So you see with a clap it takes up the whole screen again, and it's not too jittery. If you wanted to, you could further add some more checks so that if there's no wrists being tracked, then this rectangle could either fill the screen or it could occupy the center of the screen. These are extra things to think about just to make better experiences without having parts of the project flip off without the user knowing what's going on. Here is a more complete version of the logic flow that we used. I won't go into all of it, but with this, the premise is that you can reach the edges that we have here, which are more designed, and that puts the frame within your hands. Then when you clap, the effect disappears, and that lets you grab the edges to get the next one and continue that. So a part of this that we needed is a second rectangle here to cover up the first one so that it moves on to the next one correctly. So this one is set to visible until the first grab happens. So here, if we're counting, we're using these left and right grabs like we did before. And when a grab happens, it turns on a switch and sends a pulse to say that we're allowed to move on to the next step. And after that happens, we connected a series of effects into an option picker so that this state here, which was made by the logic we just saw, but with some extra complicated things as well, and to send the option of the rectangle that we see as a full frame and the one that's in between our hands to be the next one. This is connected up with the custom render pipeline. So we have our basic one going in here, but here we're using different blend modes to use as alphas. So this is in the template project. And you have one as background and one as the subtract version to be the one that's between your hands. So here I've just put lots of different colours. So let's see, if I grab this side and grab this side, I now have it in between my hands. Another thing of body tracking is that to have these wrists clap, it should be away from your face, because otherwise it gets confused between what's what. So let's switch to a video. And there we go, it's gone the next one. And if I do the same thing again, say grab and grab, we move on to the next colour. Just a little hard to pick up the clap in Studio, but if you test on your device, you'll find what's actually comfortable. For now, I'm going to use this video because it looks like he's clapping. And then again, if I move to my own video, then I can grab it and move on to the next colour. And let's look at the main project as well to see how it all comes together. Our complete version of our project, and as you can see in the scene, the setup is pretty much the same as we made in the example project, and we just have a bunch of custom shaders. So we've just polished it off to curate that experience through the space. You can see I've accidentally already triggered the first effect. So if I put my hands out, you can see that this is like the red rectangle, and now we have it in our hands. And if I clap, you can move on to the next one. And let's grab the sides. So the indicators are much more subtle here, but this was to match the visual style that we had of these effects. So I can just keep moving through to reveal some different effects. I know it's easier to do this when you're testing on device, because as you can see now, I'd keep accidentally triggering the screen grabs. And so I'm just going to leave it like that. But yeah, like here we've got the same frame scaling and frame transition in work. And this is what we'd already put in place to position the handles. These ones here on the side. This is the same logic that we used in our project as well to grab each of the sides. And this was in the more complete version of the project where you're controlling when the next value can be read. So when it increases the shader to the next one. So you can see. And here's where we've connected each of our different shaders into each sender. So we had 7, and then we fed them into these blend modes into the option picker. So here's option picker for 1. This is the one that is the background, and this is the one which is the main one. And you can see that they look similar. So, and we combine them with a multiply into the texture that goes into effect combined. That's all we have time for today. I hope this was useful in thinking about how you can use 2D body tracking or hand tracking to create some interactions for a new kind of experience within AR. Think about what feels fluid for the user, even if it does mean a lot of extra steps to catch those edge cases, like if the point's not visible, to make a smoother experience. Looking forward to what you create.